Dear students, welcome to my video class. It is the continuation class of last video. In last video, we discussed about orgel diagram, the introduction of orgel diagram and general rules of orgel diagram. Just glance the last class. In last video, the rules dn plus or minus 5 of the octahedral or tetrahedral geometry having the same energy diagram. Then dn is opposite to that of d10 minus n of orgel diagram, both octahedral as well as tetrahedral geometry. So based on that, the orgel diagram, there are mainly two types of orgel diagram. One is D orgel diagram and another one is F orgel diagram. D stands for spectroscopic notation. Capital D or capital F stands for spectroscopic notation. How spectroscopic notations are explained? So that is based on the ground state term calculation. Or suppose the spectroscopic term is D, what are the Mulkin terms involved in that? That is, so before that I just explained the terms as well as spectroscopic notation. Suppose the spectroscopic notation is S, it belongs to or it having A1G symmetry, or the Mulkin term is A1G. If P spectroscopic notation, that is T1G, and D spectroscopic notation, that is T2G and EG symmetry. If spectroscopic notation is F, that is A2G, T1G, T2G symmetry. As spectroscopic term S, P, D, F, G, H, I, J, like J, I up to I, G, A1G, EG, T1G, T2G symmetry. But we focus on S to F, or in the orgel diagram, these three are the very important spectroscopic notation. S term, P term, D term and F term. How SPDF can be calculated? That is based on the ground state term calculation or spectroscopic ground state term. That is called as GST, where ground state term is equal to 2s plus 1 L of G, where S stands for spin quantum number and L stands for orbital quantum number and L stands for angular quantum number and J stands for orbital quantum number. From D1 to D9 system, we can calculate the spectroscopic notation. It's a fundamentals of electronic spectra. So before orgel diagram, it must be know the concept, ground state term. That's why I directly explain from D1 to D9 system, where D1 and D6 system having the spectroscopic notation. From these calculation, we can explain as D, and D4 and D9 system also having the spectroscopic notation is D. Next is D2, D7 and having the spectroscopic notation is F, and D3, D8 is also having the spectroscopic notation is F. So based on why I separately explain D2 and D3 system, both are having the F spectroscopic notation, but in these two cases, D2, D7 or D3, D8 cases, its spin multiplicity 2s plus 1 is nothing but spin multiplicity. It should be changes. In here 3, but in here 4 is the spin multiplicity. It depends on the number of unpaired electron present in the D system. So that's why from these we can draw the orgel diagram. In orgel diagram, there are two types of orgel diagram. One is D orgel diagram as well as F orgel diagram. So these four system belongs to D orgel diagram and these four system belongs to F orgel diagram. Means D1, D6, D4, D9 system shows the electronic spectra under the or based on the D orgel diagram, and electronic spectra of D2, D7, D3, D8 system interpret based on the F organ diagram. Let's start the D organ diagram based on the notation or by the rule. By the rule, it explains that D1, D6 system of octahedral geometry is reverse of D4, D9 of octahedral geometry, or D1, D6 system of tetrahedral geometry is reverse of D4, D9 of tetrahedral geometry only. D4, D9 system of tetrahedral geometry, and D1, D6 system of octahedral is reverse of D1, D6 system of tetrahedral geometry. Similarly, D4, D9 system of octahedral geometry is reverse of D4, D9 system of tetrahedral geometry. So based on the D1, D6, D4, D9 system, we can draw the organ diagram, D organ diagram. From the vertical line, that is nothing but delta naught. Delta naught stands for crystal field splitting energy, or from the hypothetical D energy or zero energy state. The D organ diagram. First, I will draw the D organ diagram. That is D organ diagram. From the vertical point of vertical line, right half of the organ diagram and left hand side of the organ diagram. The right half of the organ diagram, D1, D6 system of octahedral geometry and D4, D9 system of tetrahedral geometry, and left half of the organ diagram, D4, D9 of octahedral geometry and D1, D6 system of tetrahedral geometry. And from that, the terms are, in here D is the spectroscopic notation. From the beginning, I explained that D spectroscopic notation means the terms are T1G symmetry and EG symmetry. We know that from the crystal field splitting or crystal field theory, the octahedral geometry split into T1G and EG symmetry. And left half, it explains the reverse of the right hand side. So E and T1. It means from the organ diagram, the right half of the organ diagram or right hand side of the organ diagram concept or focused on the octahedral geometry, electronic spectra of octahedral geometry, and left hand side of the organ diagram concept for the or focused for the electronic spectra of tetrahedral geometry. But both the side explains octahedral as well as tetrahedral geometry. Means it with the help of organ diagram we can interpret or we can know the electronic transition of both octahedral as well as tetrahedral geometry. But while draw the organ diagram, right half of the organ diagram mainly for octahedral geometry and left half of the organ diagram mainly for tetrahedral geometry. In tetrahedral geometry, due to center of symmetry, there is no garret and ungarret. Means there is no term for G will be used in the left hand side for only for know the tetrahedral type of symmetry. Clear? In the right side octahedral, left side tetrahedral for show the tetrahedral type of geometry E and T1. We know that octahedral geometry is reverse of tetrahedral geometry or inverse energy diagram of tetrahedral geometry. That's why in octahedral geometry the crystal field splitting lower T2G, higher EG energy level. In tetrahedral geometry, lower E symmetry and higher T2 symmetry. That's why EG and T1G, E and T1, that can be explained. The what in the from the right side of the diagram, only the one electronic transition, it moves from T2G to EG symmetry, and left half of the orgel diagram, only the one electron transition from E to T2 symmetry or E to T2 energy transition. It means electrons moves from octahedral geometry, the lower T2G and higher EG level. Clear? Means the electron which moves from lower D energy level to the higher D energy level. Suppose in D1 system, because of D1, D6, D4, D9 system belongs to D orgel diagram. Suppose D1 system means T2G EG, T2G1 EG0. The one electron, it moves from lower D energy to the higher D energy, means T2G0 EG1 type of transition. Means one electron from lower D energy level to the higher D energy level in octahedral geometry. Suppose D1 system of tetrahedral geometry. D1 system, it showing in the left half of the orgel diagram. That's why in D1 tetrahedral geometry, according to crystal field theory, E and T2, E having the lower in energy level, T2 in the higher in energy level, means E1 T0 to E0 T2 1 symmetry or T2 1 type of transition explained in D orgel diagram. Similarly for D6, means 6 electron in D6 system. From that, the electron which moves from lower T2G to higher EG level in octahedral geometry. Similarly, from tetrahedral geometry, lower E to higher T2 energy level. Suppose in case of D9 of octahedral geometry, D9 system of octahedral geometry. The D9 system of octahedral is left half of the orgel diagram. But its crystal field theory is always the lower T2G to higher EG level. In here D9 system D6 and EG3. 6 plus 3 9. In here it electronic transition from T2G6 EG3 to T2G5 EG4 transition. But its symmetry is, means Mulkin term should be inverted because of D1 D6 system of octahedral inverse diagram of D4 D9 of octahedral only. That's why its symmetry should be T2G EG only. Crystal field theory should be T2G lower in energy level, EG is higher in energy level in octahedral geometry. If it is left side, only the thing is its symmetry, Mulkin term should be changes E to T2. But the electron, it moves from lower T2G energy level to the higher EG energy level. Clear? The next move on to the F orgel diagram. From vertical line, that is delta naught, F means D2, D7, D3, D8 system belongs to F orgel diagram because of from ground state term calculation, its spectroscopic notation is F. That's why it belongs to F orgel diagram. From F orgel diagram, that is F orgel diagram. First I will write the terms D2, D7 of octahedral geometry is reverse of D3 D8 of octahedral geometry. From the rule, I will explain that D2 D7 system of octahedral geometry is inverse energy diagram of D3 D8 system of octahedral geometry. Next, D2 D7 octahedral geometry is reverse of D2 D7 system of tetrahedral geometry, and D2 D7 of tetrahedral geometry reverse of D3 D8 of tetrahedral geometry. From rule 1 to rule 6, we can explain the term D2 D7 of octahedral geometry is reverse energy diagram of D3 D8 of octahedral. Then D2 D7 of tetrahedral is reverse energy diagram of D3 D8 of tetrahedral geometry. So based on that is the F term, that is the P term. Why P term involved in the DF organ diagram? Because the spectroscopic notation having in here from the ground state term, both the spin multiplicity should be same. Both the spin multiplicity should be same. Suppose D2 system. In D2 system, only the 2 electrons, 2, 3, 4, 5. From calculation, we can explain that only the 2 electron. In here, spin should be half plus half 1. Therefore, S is equal to 1 means 2S plus 1 is equal to 3. So, the spin multiplicity should be 3 in lower energy or as well as higher energy. Means that's why in a D2 system, 3F and 3P both are having the same spin multiplicity, and it explains same energy in electronic spectra. That's why the P term is also involved in the F organ diagram. Next, from the spectroscopic notation having its Mulkin terms, it explains as T1G symmetry from the octahedral geometry side, T2G and A2G symmetry, and that is the P term having only the one, that is T1G. For differentiation of T1G and this T1G, that is T1G of P. P stands for this symmetry or this symmetry due to P spectroscopic notation, and which is inverse of left side of the diagram. That's why in left side of the diagram, the higher energy goes to lower in energy level. And next T1G, that is T1 and T2 and T1 of P. T1 of P. So in here from octahedral geometry of T2 D7 system, it is again in the explain the D organ diagram, the right half of the organ diagram and left half of the organ diagram. The right half of the organ diagram D2 D7 of octahedral and D3 D8 of tetrahedral geometry, and left half of the organ diagram D3 D8 of octahedral and D2 D7 of tetrahedral geometry. Only thing is right half of the organ diagram mainly for electronic spectra of octahedral geometry, and left half of the organ diagram mainly focused for electronic transition of tetrahedral geometry. That's why the term G cannot be used in left hand side, but both the diagram or both side it explains the electronic spectra of octahedral as well as tetrahedral geometry. But for the consideration, these are octahedral, these are tetrahedral. In octahedral geometry, the first transition from T1G to T2G, and second transition is T1G to T1G of P spectroscopic notation, and third transition is T1G to A2G symmetry. In octahedral, D1, D2, D7 of octahedral, D3, D8 of tetrahedral geometry, and D3, D8 of octahedral, D2, D7 of tetrahedral geometry. The first transition due to A2 to T2, and second electronic transition from A2 to T1, and third electronic transition is A2 to T1 of P spectroscopic notation. There are the means from the OR-gate diagram we can interpret the number of electronic bands observed in the suitable complexes. D2, D7, D3, D8 system having 3 electronic bands are observed based on the D OR-gate diagram. It is a qualitative analysis. Number of bands are observed but cannot be calculated. The delta naught means its splitting energy cannot be calculated from the OR-gate diagram because of it's only for the qualitative analysis, not for the quantitative analysis. Suppose D2 system of octahedral geometry. It T2G lower in energy level, EG in the higher in energy level. D2 system means T2G to EG naught. Because of these octahedral or tetrahedral geometries, or from the OR-gate diagram, only the electronic spectra of high spin complexes only, means all the ligands are weak field complexes, or it belongs to weak field. That's why according to Hund's rule, the electronic are arrangement from lower in energy level. T2G to EG naught, it excited to T2G1 EG1, T2G1 EG1 or T2G0 EG2. Only the thing is, in from higher energy level, all the two electrons moves from lower D energy to the higher D energy level. As its energy gap, that is nothing but delta naught. This energy gap or delta naught increases, it moves on to the higher in energy level. It moves on to the higher energy level means it moves from visible region to the UV region. Means its colored complex, the colored transition to the colorless transition. Similarly, for in these two cases, if D2 system of tetrahedral geometry means the left half of the OR-gate diagram means E is the lower in energy level, T2 is the higher in energy level. Means E2 to T2, it moves from the first transition E1 to T21, next is E1 to T21, and the third one is E0 to T22 transition. Means two electron moves from lower D energy level to the higher D energy level. Here one thing is why these lines are curved nature, because of the repulsion between F term as well as P term should be maximum. Means its repulsion increases, the curved nature will be increases. That's why it is the non-crossing rule. Non-crossing rule in explaining in the F OR-gate diagram. Non-crossing rule means in here the terms are T1G, T2G, A2G. These three terms are the F spectroscopic notation, and T1G of P or T1G from the P spectroscopic notation. These three terms are crossed with one another from octahedral to tetrahedral or from right side to left side. They are crossed with one another and meet in a one point, that is the center point. But these P term cannot be crossed with the lower in energy level or zero energy level. That's when these F2 P term are non-crossing rule. Based on our application of OR-gate diagram, means to interpret the electronic spectra of D1 to D9 system. Electronic spectra of D1 to D9 system means the number of electronic bands can be calculated or qualitatively calculated by the help of OR-gate diagram. The OR-gate diagram, either the spectroscopic notation is D, it belongs to D OR-gate diagram. If spectroscopic notation is F, it belongs to F OR-gate diagram. Consider one example for the application of OR-gate diagram. D1 system, the example is TiH2O 6 times 3 plus. Titanium in here, titanium in +3 state. The H2O aqua ligand, it is weak ligand, that's why it is an high spin complexes. It's a neutral ligand, that's why directly we can consider as titanium in +3 state. Titanium in +3 state means belongs to D1 system because of scandium, titanium, vanadium means it's a D2 and Ti +3 state, that's why it's a D1 system. Means D1 system lower octahedral geometry due to lower T2G, higher Eg level. Only one electron and it moves to lower energy to the higher in energy level. Means electronic transition is T2G1 to Eg1, means lower D energy to the higher D energy level. Based on the orgel diagram, we can interpret the number of bands in the D1 system. D1 system means from the D orgel diagram, D1 means its spectroscopic notation is 2D because of S is equal to half, 2s plus 1 is equal to 2 and L value as 0, 1, 2, 3 so on. It indicates S, P, D, F so on. As angular quantum number is 0, 1, 2, 3 so on, it indicates the capital S, P, D, F means its spectroscopic notation. In here L is equal to 2, that's why its spectroscopic notation is capital D. Therefore it belongs to 2D ground state term. That's why the D orgel diagram. The D orgel diagram, the lower D1, D6, D4, D9 system. But we can only focus on the D1 system. D1 of octahedral is right half of the orgel diagram. Only we can draw the right half of the orgel diagram, that is 2D, the lower to T2G and higher to Eg level. What is the 2? It indicates spin multiplicity. 2T2G electronic transition, it moves from 2T2G to 2Eg level. Means the T2G1 to Eg0 electronic transition from T2G0 to Eg1 transition. So similarly we can explain the electronic spectra of D2, D3, D4, D6, D7, D8, D9 system based on the D orgel diagram as well as F orgel diagram. So some other concept we can discuss in the next video. Thank you for watching my video.